Hi students, in this video we are going to discuss about least square approximation. Least square approximation is a method for finding the best fit line or curve that passes through a set of data points. It is commonly used in regression analysis where we want to find a linear relationship between two variables. Regression analysis already we have discussed in probability and statistics. Here best fit line or curve. So line or curve, generally we used line y equal to mx plus c, slope and intercept form, and curve I am going to take the parabola y equal to ax square plus bx plus c. Okay, so how we form the equation of the line y equal to mx plus c for the line and y equal to ax square plus bx plus c and passes through a set of data points. While we have only set of data points more than 2. Suppose we have 3 or 4 data points. From the data points, we have several methods to form the equation of the line and equation of the parabola. So among the several methods, which one is going to be best fit? The least square approximation method gives the best one. How we know? See, the idea behind the least square approximation is to find the line or curve that minimizes the sum of the squared errors between the actual data points and the predicted values on the line or curve. In other words, we want to find the line or curve that is as close as possible to the actual data points. So let us see one example, then we can easily understand the concept. See, before that, let me explain the procedure how we use the least square approximation method. Suppose we are taking any equations. I am going to take this equation like a1x plus b1y plus c1z equal to d1, and the second equation a2x plus b2y plus c2z equal to d2, and third equation a3x plus b3y plus c3z equal to d3. Like that we can have n number of equation. So I consider 3 variables with 3 equation. 3 variables with 3 equation. Now as usual procedure, you know how we form the system of linear equations into the matrix form, like ax equal to b. Here a is nothing but collection of coefficients of this equation. So coefficient matrix, x is the column matrix of unknown variables, b is the column matrix of the constant. So a, what is the coefficients of the equation? a1 b1 c1, a2 b2 c2, a3 b3 c3. So a1 b1 c1, a2 b2 c2 and a3 b3 c3. Here we are using the unknown variables x, y, z. X, y, z. What is the constant matrix? The numbers are elements without variables. d1, d2, d3. d1, d2, d3. So this is required matrix form of the system of equation. In school days, you have solved this type of equation. There we know what is the solutions of this equation. It may be unique solution or infinite number of solution or inconsistent, that is no solution. That is what? No solution. Okay. So after you solve this equation, we have the solution x naught. So this x naught value equal to x naught, y naught, z naught. X naught, y naught, z naught. Okay. Then we substitute the main equation, replace by these values by x naught, y naught and z naught. Okay. So right, after finding the solution, you form the equation of the line, equation of the curve. How we know that best fit? Through the error concept, by norm ax naught minus b. If this difference between these two very close to 0, then what we have predicted value, that is correct. If it is more errors happen, our predicted value will be judged more, okay, will be analyzed more, okay. Now let us see one example. Find the least square line. Find the least square line fitted to the data 1, 1, 2, 2, 3, 2 and 4, 3. So I am going to take the input values x1, output value y1, and here input value x2, output value y2, and here input value x3, output value y3, and here x4 and y4. The question is least square line. Generally we use the equation of the line y equal to mx plus c. I am going to use y equal to ax plus b, okay, y equal to ax plus b. Here there are data are given x1, x2, x3, x4 and corresponding outputs y1, y2, y3, y4. See, y1 equal to a into x1 plus b and y2 equal to a into x2 plus b and y3 equal to a into x3 plus b and y4 equal to a into x4 plus b. Okay, now this is required system of equation. Now the system of equation, in the system of equation we substitute the actual x1 and y1 value. Okay, so y1 value equal to 1 equal to a into 1 plus b, in second data 2 equal to a into 2 plus b, and third equation 2 equal to a into 3 plus b, and from the fourth set 3 equal to a into 4 plus b. Now from the system of equation you may form the matrix form ax equal to b. So take the coefficients alone. Here what is the coefficient? A and b are unknown variables. The corresponding coefficient 1, 1, 2, 1, 3, 1, 4, 1. So b into 1, b into 1, b into 1, b into 1. So I am taking here the coefficients alone 1, 1, 2, 1, 3, 1 and 4, 1 into x value a b equal to what is b? The constant matrix 1, 2, 2, 3. 1, 2, 2, 3. Okay. In school days, when we solve this matrix form of the system of equation, we have the square matrix, but here rectangular matrix. So when we start the solution, initially we have starting trouble to find the solution. So in this case, normal equation help us to solve the equation. What is the normal equation? Formula a star a into x equal to a star b. So a star equal to a conjugate whole transpose. So here suppose we have the complex numbers inside the matrix, first we take conjugate, then only transpose. Here the matrix contains only the real number, so a star we can find directly by a transpose. Okay, so before we solve the equation, instead of solve this equation, solve the normal equation. So to form the normal equation, the required data is a star b. Now we find a star a equal to a star a transpose 1, 2, 3, 4, 1, 1, 1, 1, and a matrix 1, 1, 2, 1, 3, 1 and 4, 1 equal to multiply this row and column 1 into 1, 2 into 2, 3 into 3, 4 into 4. So 1 plus 4 plus 9 plus and 16. And here all the multipliers are 1. So 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1. Here all the first multipliers are 1. So 1 plus 1, 2 into 1 plus 3 into 1 and 4 into 1, and all numbers are 1, all numbers are 1, 1 plus 1 plus 1 plus 1. Now add these values: 5, 14, 30, 30, and 3, 6, 10, 10, same elements here, 10. So sum of 4, 1, 4. So A star A is over. Now A star B, A star A transpose 1, 2, 3, 4, 1, 1, 1, 1, and constant matrix B. Constant matrix B 1, 2, 2, 3. Okay. Now multiply these two matrix: 1 into 1, 1, plus 4, plus 6, plus 12, and 1 plus 2 plus 2 plus 3. Answer is 5, 11, 11 plus 12, 23, and 3 plus 2, 5, 5 plus 3, 8. Now the normal equations becomes A star A into X equal to A star B equal to A star A, 30, 10, 10, 4, 4 into X A B and A star B, 23, 8. 23, 8. Okay, if it is 3 by 3 matrix, you may solve by Gauss elimination method, Gauss Jordan method, Gauss Jacobi method. Now this 2 by 2 matrix will know. We can easily solve by direct method, or we may apply here Gauss elimination method also. I am going to use Gauss elimination method: 30, 10, 23, 10, 4, 8. This is the required augmented matrix. Now this is the pivot element 30. To make this element as 0, by multiplying by 3. So 30, 10, 23, multiply by 3, 30, 12, and 24. Okay. Now R2 minus R1, R2 minus R1, (30, 10, 23). Now R2 minus R1, 30 minus 30, 0, 12 minus 10, 2, and 24 minus 23, 1. So by back substitution method, we can get 2b equal to 1, b equal to 1 by 2, b equal to 1 by 2. Now take the second equation, 10a plus 4b equal to 8. So 10a plus 4 into 1 by 2 equal to 8. So 4 by 2, 2. 2 bring the right hand side, 8 minus 2, 6. So 10a equal to 6, which implies a equal to 6 by 10, that is 3 by 5. 3 by 5. Now successfully we found the solution, that is x naught equal to ab, a value 3 by 5, b value 1 by 2, a value 1, b value 1 by 2. Okay. So what is the given equation? Y equal to ax plus b. Okay. So y value 3 by 5, sorry, y equal to a value 3 by 5 into x plus b value 1 by 2. So what we receive the data only know, for the data this is the best equation. This is the best equation. So how we conclude this is the best equation? Let us understand by the error concept. See the error formula. norm ax naught minus b very close to 0. So find ax naught first. Matrix A 1 1 2 1 3 1 and 4 1 into x naught 3 by 5 and 1 by 2 equal to 3 by 5 plus 1 by 2. Second 2 into 3 6 by 5 plus 1 by 2, 9 by 5 plus 1 by 2 and 12 by 5 plus 1 by 2. Taking LCM 5 to 10. So simply cross multiply the value. 6 plus 5 11, 11 by 10 and 8 plus 5 13 by 10, 18 plus 5 23 by 10 and 24 plus 5 29 by 10. Or use the decimal values 1.1, 1.3, 2.3 and 2.9. Now a x naught minus b equal to 1.1, 1.3, 2.3, 2.9 minus b value 1, 2, 2 and 3. Sorry, 6 into 2 12, 12 plus 5 17. So here instead of 1.3 we used 1.7. Okay, here too we change 1.7. So what is the answer? 1.1 minus 1 0.1 and 0 minus 0.3 and 0.3 and minus 0.1. Or using the fractional numbers 1 by 10 minus 3 by 10, 3 by 10 and minus 1 by 10, minus 1 by 10. Now norm of a x naught minus b, norm of a x naught minus b. So norm u equal to square root of inner product of u comma u. So we know the concept inner product of u comma u. See what is the vectors. So here both two vectors are same u. So root of 1 by 10 into 1 by 10, 1 by 100 plus minus 3 by 10 into minus 3 by 10, 9 by 100, 3 by 10 into 3 by 10, 9 by 100 plus 1 by 100. So square root of, take LCM 100, 1 plus 9 plus 9 plus 1 equal to, this is 20 by 100, answer root of 0.20 or the value 0.447. So compare these values. 0.447 is the close to 0. So what we have predicted the equation, that is best equation. Okay.